We just looked at this variable called housing, which has two levels, right? Yes and no, right? Folks who own a home or folks who don't own a home, right? What happens when we have more than two levels, okay? And we will have many such instances where we'll deal with variables with more than two levels. So, for example, in this case, we have married, single, and divorced. Just like before, we are going to create a copy and work on that copy. Okay, you take this, and what we are doing here is that we are applying this lambda function. Okay, where we are saying that it's 0 if x equals married, else 1 or else 1 if x equals single, else 2, right? So basically anyone who is divorced, I believe, is going to get the value of 2. Okay, and this is what we have. So 0, 1 and 2. So basically married, single and divorced, we coded at 0, 1 and 2. But to a model, I think it might appear that 0 is less than 1 and 1 is less than 2, okay, which is not truly the case because there is no order to these levels in a variable, right? So I think we right away know there is a problem with the way we have coded it. So what is the right way to code? Okay, we're going to start off again with that the temp data frame. Okay, and what we're going to do is we're going to create three different columns. Okay, so first we're going to apply. Okay, so we know how the apply function, this lambda function works. Okay, if x equals married, we apply 1, else 0. Okay, and we create three different columns. Okay, and we take this thing, we copy it here, and we create a new column called marital underscore married. Okay, so basically we're creating three different variables and adding it to the existing data set. Okay, and to single, if it's single, we want a value of 1, otherwise 0. Same thing if it's divorced, we want a value of 1, otherwise 0. Okay, and we are doing the same thing, and we are going to look at this four different the original variable, which is marital, and the three new variables we have created, right? And as you can see, if you look across, if a person is married, he will have a value of 1 in that column. Okay, in the marital underscore married column, and the other two columns are going to have 0. Okay, if a person is single, this is going to be 0 in married, single in 1, or 1 in single, and 0 in divorced. Okay, same thing. And if you come across something where it's divorced, you will see it's 0 here, 0 here, and 1 here. Okay, and you can see that these are all zeros. Okay, let's see whether we can find any of them which are say dot head, say 25. Okay, let's see whether we find any divorced. Okay, right here. So you see, when you come across something which is divorced, or someone who is divorced, you will see 0 under married, 0 under single, and 1 under divorce. So basically, if these two are zeros, it automatically implies that it's the third option. Okay, so you can see that there is some redundancy in this column. So you don't need to have all three columns. For example, just like we just talked about, right? So if column marital underscore married is 0, column marital under single is 0, that automatically implies that the person is divorced. Okay, because there are only three possible choices, right? So if we feed this three, of course we're not going to feed all four columns or all four variables to a model. If you wanted to sort of model this marital status as a variable, we are going to, of course, delete the marital variable column because it's already there, and we already use that to code three different variables, right? And the tool will not even be able to understand that column. Okay, so let's first what is this? What are we doing here? Okay, so I think the same thing. Okay, so I was just trying to point out the divorced column, right? And we are trying to just isolate the divorced column here, and you see that when this is 0, this is 0, this is 1, right? So to a model, you don't want to actually include all three columns. Okay, because that creates a lot of problems. Okay, it leads to something called a multi-collinearity. We'll get to that. Okay, it's a big word, but all it means is that when you have three different levels and we include all three levels, it creates a complexity in the model, and it will yield bad outcomes. Okay, bad forecasting outcomes. Okay, so what you typically do is we typically drop one of the columns. So when you drop, say, marital underscore divorced to a model, okay, let's say here we are dropping marital underscore married. So let's say we drop marital underscore married. If marital under single is divorced, if marital dot divorced is, sorry, if marital dot single is 0, if marital dot divorced is 0, that automatically implies that it's marital underscore married. Okay, so think about that. Okay, so basically what we are trying to do is we're trying to not add this third variable or third level, which is redundant information. We are only adding the two levels which imply one or the other or the third one, right? So if these two are 0, then it implies that we are talking about marital underscore married. And this is a typical model. Okay, so these are the parameters of a model which we are going to talk about when we actually are going to do prediction and all. But just to give you a snapshot of what a typical model will look like, of course you will have other variables which are going to have their own coefficients. Okay, these are basically parameter estimates of when this is 1 and this has some value, this one is going to be 0. This along with this is going to influence the level or the variation in y. Okay, y is the dependent variable. These are all independent variables. I don't want to get too much into that, but remember this thing about coding dummy variables, because we are going to get to that. We're going to use that a lot. Okay, and typically you want to pick the level with the most counts. Okay, and you will see that in this case, the reason we have picked in this model, we have picked marital underscore married as the reference level, as the baseline, because it has the most count. Okay, it has the highest count, so it is the top frequency, and you can find that out using this something called dot describe. I think we have done that before. Okay, and we are going to drop that the column. We are going to drop this column and this column from the model. Okay, we are going to drop this column and this column from the model, because this is the baseline, and this we don't need in the model because this will just mess up the model. Okay, so and we're going to drop that model. Okay, and we get our data frame which has this two levels and the rest of the data. Okay, instead of doing this manually, okay, we applied this lambda function here to do that, right? There is something called get dummies. Okay, we'll again create a temp data frame. Okay, and we'll see that what this does first. Okay, so when you say get dummies, okay, it will. Okay, so we are getting dummy variable on the temp data frames for the marital column, and you will see that you will get those columns automatically. Okay, instead of doing it using lambda function. Okay, so we're going to do that, and we're going to assign it to the data frame, and this is what the data frame is going to look like. Okay, and you have these three levels, and you're going to drop one of them, and that's your final data frame. Okay, and you can use that to do whatever modeling you want to do. Okay.